Guys, this video is going to talk about intersections of chords. Remember that a chord in a circle, a chord is a line segment with two endpoints on the circle. So it stays within the circle. Okay, it starts on some part of the circle, goes through it, and ends at another part and never exits. So this is what it looks like if you have one chord. Here's two chords, which we're going to be discussing today. And then here we've got several chords. So there is no limit to the number of chords inside of a circle. How many chords can you count in that third circle? So if you look, we have one right here, we have two, we have three, we have four, and we have five. So we have a total of 5 chords here. Two chords inside a circle must always intersect. This is going to be a false statement because I can draw on another chord right here. Those two don't intersect. If you look over here, segment AC and CB, they don't intersect. They might meet at an endpoint, but they don't actually intersect. So it do not have to intersect. So chords do not have to intersect. When they do, this is what we look like. Okay? So we're going to name the two chords first. Starting, we've got segment A, B, those are the endpoints. And the other one, we have segment C, D. Now, when we have these two chords that intersect, they're always going to create 4 smaller parts. Okay, and that's what we're going to be working with on this. Okay, so here we want to name these 4 small parts. So if we take segment A, B, one of the chords we had, one part, that E is going to be where it divides it. We have segment AE. We have segment EB. Going to the other chord, we have segment CE, and we have segment ED. And when we are trying to figure out the length of any of these, we do have a formula, a nice, sweet, easy formula. Okay, and the products of their parts are going to be equal. Okay, so what that means is all 4 of these little parts, what we're going to do is we're going to take this formula, we call it part times part. So one part of a chord times the other part of the chord. We set this equal to, go to the other chord, and we multiply its 2 parts. And we'll see this, and I'll be doing different colors. If you would like to get different colors, I'm going to be using 4 colors to represent these different parts on the next page. So here we have this. The first problem here, we're just going to solve for x. So let's look at this part times part stuff going on. All right. So what we're looking at is this chord right here. We're looking at this part. So we would have x. We would multiply it by the other part of the same chord, 15. This would all be equal to, let's go to the other chord now. We have this part, 5, times the other part of that same chord, the 9. Now we see how we got these different colors can help us out. When we multiply x and 15, we get 15x. We multiply 9 times 5, we're going to get 45. And then we just divide both sides by that 15. And x is going to equal 3. Okay, part times part equals part times part. Let's take a look at the next one. Here we have part times part. So we have the x times 4 all equal to, we have, it doesn't matter, like with that one, doesn't matter if I do x times 4 or 4 times x, because with multiplication, doesn't matter which order the numbers go in. So here we have 5 times 8. And again, doesn't matter whether it's 5 times 8 or 8 times 5, does not matter. Multiply these, we get 4x. Multiply these, we get 40. Divide both sides by that 4. X is going to equal 10. So, simple, easy, one variable. Let's start looking at what happens when we start changing some things up. Now we have a coefficient, but we also have a square. No big deal. Check this out. Started off exactly what we were doing. We have our part, 2x squared, times the other part, 12, all set equal to part 9 and that chord's other part 16. When we multiply the 2x squared times the 12, it's just like if that square wasn't there, we'd multiply the 2 times 12 to get 24x, but we need to bring down that squared. On the other side, 9 times 16 is going to give us 144. So order of operations, we work backwards. We need to get rid of that coefficient first. When you have a square and you're working backwards, okay, when you have an exponent, that's the last thing you take care of. So we divide both sides by 24 first. We're going to get x squared equals 6. And now we take the square root, and we're going to leave this as a simplified radical, which the square root of 6 is already simplified. So here's your final answer. Example number 4. Let's go ahead and set up our part times part. I just always like to start with the variable. Part x plus 2 times part. Now I'm going to go ahead and put this 15 because I know I'm going to have to distribute. I'm going to go ahead and put the 15 out here so I see it how I normally do. This will be equal to the other chord, part 10, times the other chord's other part, 24. So we're going to distribute over here on the left to get 15x. 15 times positive 2, get a positive 30. We set this equal to 10 times 24, rules of 10, just add a 0, 240. And so we just have 2 steps left. Subtract that 30 from both sides. We get 15x is equal to 210. Divide by that 15. X is going to equal 14. One more. We're going to end up with variables on both sides for this guy. All right, part. Got x minus 9 times the other part, 24. Again, I see that I'm going to end up having to distribute, so I'm going to go ahead and put the 24 out here. The other chord, I'm going to put my equal sign. I'm going to have distribution again because of this x minus 5, so I'm going to put that 21 up front. You don't have to, but it's normally what we see. And then the x minus 5 right here. So we have to distribute on both sides now. 24 times x gives us 24x. 24 times a minus 9 is going to give us minus 216. Roll over to the other side. 21 times x gives us 21x. And 21 times a minus 5 is going to give us a minus 105. All right, I'm going to move my smaller variable, this guy right here, the 21x. Subtract 21x from both sides. We end up with 3x minus 216 equals a negative 105. Don't forget that negative. Right? The negative 216 is go over to the other side. Let's add. So now we have 3x equals, we have a negative, we're adding a bigger positive, so we're going to end up with a positive number, 111. Divide both sides by 3 and we are done. X is going to equal 37. All right, part times part equals part times part.